You know, one of the things that I'm actually moving to the fourth presentation, but I think it is important that we discuss this issue right now because Sunita made it very clear why current emissions are not important, why cumulative is important. Now, one of the things that happened with the fifth assessment report of IPCC, was actually discussion on this chart. And for the first time, about 25 years of climate science, it is now established that temperature is linked to cumulative emissions. There was a lot of doubt on this issue, that whether temperature is linked to when it was emitted, is it linked to current emissions, is it about how much influence stock, past emissions have on temperature, was an uncertain science. However, there was a lot of work that happened in the last 10 years. And essentially, we now have a mathematical equation which says that if you emit about 500 billion tons of carbon, your temperature will increase by a degree. It doesn't matter when have you emitted. That's what carbon budget is all about. So if the world wants to restrict temperature to 2 degrees, not more than 2 degrees, we are talking about not more than 1 trillion ton of carbon, or not more than 4 trillion tons of carbon dioxide equivalent emissions. Okay? So I just want to make it clear why Sunita was focusing so much on cumulative emissions, because temperature is linked to cumulative emissions. Okay? India can decide, suppose there is a distribution of carbon cake. Okay? India can decide that I want to emit today, or maybe I want to emit in 2060. It will not have significant impact on temperature. Temperature, therefore, has everything to do with cumulative emissions. How much have been emitted to a certain point of time. So this was the point I just wanted to make, because this argument is always not taken into consideration, and current emissions becomes the most important issue for discussion. And I'm sure that is going to happen in Paris as well. They will keep talking about current emissions and increasing current emissions of developing countries, forgetting that at the end of the day, when the complete cake is eaten, that will decide what will be the temperature increase, not what we are going to do from now, say for another 10 to 15 years. Let me go back to, we have post-lunch session on impact, but I want to, yeah. Sure. So what I am going to do therefore is quickly talk about again an important chart from IPCC, okay, which tells you that let's look at 5 important issues, impacts that is going to happen because of climate change, and how they are related to different temperature increases. Now, the first impact is on unique and threatened ecosystems. For example, people coming from Bangladesh will consider Sundarbans as a unique and threatened ecosystem. People in Himalayas will consider a lot of ecosystem in Himalayas as unique and threatened. The second impact is extreme weather events. The third is distribution of impact globally, whether the impact will be localized, whether it will have global impact. The third is global aggregate impact. It means world as a whole, what it is going to experience. And the last is large scale singular events. Anyone who has seen the movie 2012, that would be the large scale singular event. Now, if you look at it, if you take these 5 impacts, you find that we are here right now. We are at about 0.85 degrees temperature rise over the 1850 levels, pre-industrial levels. It already has moderate impact on unique and threatened ecosystems. And therefore, when people in Himalayas are saying that they are experiencing less snow, or that there is changes in biota, that is because at less than 1 degrees, we are likely to see moderate impact on unique and threatened ecosystem. However, even at 1 degree temperature, we are not likely to see large scale singular events like 2012, the movie 2012. Okay. For that, we have to reach somewhere about 2 degrees. And that's why people keep talking about limiting the temperature below 2 degrees, because in their idea, the impact is in terms of large scale singular events. However, at 2 degrees, you will have large scale devastation of unique and threatened ecosystem. Okay, at 2 degrees, for example, you will have very, very high impact on unique and threatened ecosystem. You will have very, very high extreme weather events, which will affect the poor. Okay, you will have global distribution of impacts. You will have less global aggregate impact. So at the global level, you are likely not to see such extreme impacts, but localized level and on threatened ecosystems, you are likely to have huge impacts even at 2 degrees. So when people say that we need to limit temperature rise to 2 degrees, they are looking at the world. They are not looking at individual communities, individual countries, because they are going to get devastated even at 2 degrees. And this is current knowledge. This knowledge will change, I'm sure, in next 5 years when IPCC will come out with this next report. But in general, I'm just going to summarize that since 1950s, many of the observed changes that has been recorded has been unprecedented. Okay, there is no doubt about it. We have documented data on ocean acidification as well as sea level rise. We have reduction in snow cover, Arctic ice cover. We have extreme weather event which is increasing. And most importantly, now biologists are telling us that animals have, plants have started to adapt, so-called adapt. Okay, and there's a lot more research which is coming from biological science background on how animals are coping with these changing, animals and plants are changing, coping with these changing temperature increase. I'm sure a lot of you would have seen IPCC AR5 report on how sea level has increased by about 0.19 meter since 1900. About the increase have been significantly high in last 15-20 years, almost double the rate of historical increase in sea level rise. We have data on much less concrete data, but significant data on ocean acidification, because ocean is the biggest sink for carbon dioxide today. Carbon dioxide is being absorbed by ocean, getting converted into carbonic acid, and therefore the science is quite simple, that ocean acidification will continue to happen if we keep increasing the emissions of carbon dioxide. We have data on shrinking Arctic ice cover, but in Himalayas, for example, we now have a lot more research that is happening in terms of shrinking glaciers in the Himalayas. Extreme weather events, I think Roxy is here, but this is something that we are going to discuss more and more. But I just want to put this number on the table. If you look at average number of extreme weather events per year by decade, okay, and these are data from insurance companies, frankly, and they care about it because they have to pay out money, okay. So money is important. If you are really looking at good data, go to insurance companies, okay. So if you look at average number of extreme weather events per year by decade, it was about 2.5 per decade in early part of 1900, okay. We are now looking in 2000 and 2010, 350 extreme weather events per year during the decade of 2000 to 2010, okay. And a large number of these are hydrometeorological impacts, which are related in many ways to climatology, okay. It is about droughts, floods, hailstorm. Earthquake is not related so much to climatology, okay. These numbers 350, about more than 2/3 are because of which we can say is related to climate systems. So there is a clear evidence of increasing extreme weather events in the last 100 years. In India, for example, and you know, I just wanted to bring this to the table because we have so many people from Himalayas here, okay. In 2005, I don't know how many of you know what happened in Mumbai. Within an hour, there was 1,000 millimeter of rainfall, and we had, you know, 5,000 people dead in the city of Mumbai, okay. In 2010, we have people from Leh here. We had a cloud burst. In 30 minutes, we had about 250 millimeters of rainfall, which is actually equal to what Leh would get in a year. Happened in 30 minutes, we have 255 people dead. In 2013 in Uttarakhand, we had about 6,000 people dead because of all the destruction that happened of extreme rainfall events. In Jammu and Kashmir in 2014 and 15. So I'm just giving you some data point to understand how parts of Himalayas And these are not recording, you know, so-called small extreme weather events. Okay, there must be tens and twenties of them that I could record here. I'm just giving you the highlight which has happened in the last 10 years. And we have papers which are saying, which actually now says that the incidence of very heavy rainfall events are increasing in parts of India. In the Indian subcontinent, we are now experiencing more and more heavy rainfall events, and there is a decrease in moderate rainfall events, which are actually very important for agriculture. Agriculture requires moderate rainfall, not heavy rainfall. So that's where you can also link it to the agricultural productivity issue. The last thing is, and this point Sunita made, but we now have data to show that poor countries and communities are suffering the most. Before the 5th assessment report of IPCC came, there was this report on extreme weather event that IPCC came out with, where they tried to put some number on the losses that countries are experiencing because of climate change. Now, if you look at this data, between 2001 and 2006, low-income countries lost about 0.3% of their GDP due to extreme weather events. Low-income countries, LDCs countries, lost about 0.3%. Developed nations lost about 0.1% of their GDP, whereas rapidly developing countries like India, China, South Africa, Brazil lost about 1% of their GDP due to extreme weather events. So what you see is, in terms of wealth that countries have, developing countries, rapidly developing economies are losing much more due to extreme weather events than developed countries. This data just I wanted to put out. But let me end by saying that impacts are going to get worse. And the first chart that I showed you, as we keep increasing the temperature, we are going to experience more and more adverse impacts of climate change. The fact is that we are in for 0.3 to 0.7 degrees temperature rise in any case. Okay. The inertia in the climate system, if today, for example, the world decides that we are going to become net zero emitters, which is not going to happen even in the next 20 years. Okay. But let me give you a hypothetical scenario. Even if we decide that become net zero emitters today, we are in for another anywhere between 0.3 to 0.7 degrees temperature rise between 2016 to 2035, which means at the low end we are in for about 1.2 degrees temperature rise, at high end at about 1.5 degrees by 2035. Okay. Now consider the case that we are adding greenhouse gases every year and at a much more rapid pace. The world has not reduced its emissions. In fact, the emissions are going up. So let me end, and we will break for tea. We'll come back. Please note down your questions you have on the first two presentations. We will address that first, and then we will move to the next two presentations. So we are late by 10 minutes. Supano? Is Supano around here? No. Okay. So we are breaking for tea for 15